Today we will be talking about derivatives of inverse trig functions. To start off, we're going to talk about the derivative of the inverse sine function, or sometimes called the arcsine. So what I like to do personally is follow this formula here. It's basically, in order to find the derivative of the inverse sine, it's the derivative of the u component, u prime, divided by the square root of 1 minus u squared. This simply just makes it easy for me because I just break it out to components. So I'll find my u, and I'll find my u prime, and I would just plug it into the formula, and maybe do a little bit of algebraic manipulation based on the function, and there's my answer. This is actually the more common equation, and I just prefer this because it's easier for me. If you want to use this, it's perfectly fine. I'll prove this formula later on in the video. Alright, so let's start with an example first. The function inverse sine of e to the x squared. How are we going to find the derivative of this? Let's first of all find our u. What's our u? Our u is going to be e to the x squared. Now we got our u done, right? What's the next step we want to do? Find the u prime. So remember, we're trying to solve using this formula. So if we have our u, only thing we need is the u prime. So let's get our u prime. In order to solve this, you actually just need calculus 1 knowledge. So remember, the derivative of a e component is going to be the e component times the derivative of the exponent. So we have the e component, and the derivative of the exponent is 2x. And now we have our u prime and our u. What are we going to do? We're just going to go back and just plug it into this formula. So if we plug it in, we'll have our 2x times our e to the x squared divided by the square root of 1 minus e to the x squared squared. Usually this is enough for your answer, but if your professor is like mine, he wants you to complete it fully, so we'll just square this, and the actual answer is this: 2 to the x times e to the x squared divided by the square root of 1 minus a to the x, e to the 2x squared. Alright, so now let's prove the other formula. In order to prove this formula, let's start off with the basics. Some y function is equal to the inverse sine of x. Right? So what we like to do is first take sine of both sides, and we make it into something we can manipulate. Boom. Now we have sine of y is equal to x. What are we going to do now? We are going to try to get the derivative. So we're going to take the derivative of both sides with respect to x. When we take both sides with respect to x, we don't get x prime because remember it's respect to x. We just get 1. The derivative of x is 1. The derivative of a sine function is cosine. This is the cosine of the function. But we have to remember that since it's with respect to x, we have to take the derivative of the y function that's in the sine. So derivative of y is y prime, right? And since we're trying to find the derivative, we just set everything equal to the derivative, and we get y prime is equal to 1 divided by cosine y. So remember, the formula we're trying to prove is this formula. So how did we get this formula from that? Simple. You make a right triangle, right? You input x is equal to sine y. Y is our angle. X is our opposite side. 1 is our hypotenuse. Through the Pythagorean theorem, we can conclude that the adjacent side is 1 minus x squared. Right? So once again, let's go back to original formula. Remember, y prime is equal to 1 divided by cosine of y. We just concluded that. Now let's input our cosine. let's input our cosine into that formula. What do I mean? So cosine is adjacent over hypotenuse. If we input that, we have the square root of 1 minus x squared divided by 1. And we just input that into uh, our derivative we just concluded, and we will get this. Boom, the formula. That is how we prove that the inverse sine of x is equal to 1 divided by the square root of 1 minus x squared. Thank you for watching. Please comment, like, and subscribe. All positive and negative feedback is appreciated.